what you do with an introduction like that. Every one of us should have a friend like Keith Buckley, and I trust you do. Tonight's talk is technically based, so I'll only have one request, and that is when I'm through with the presentation involving the slides, I want you all to applaud loudly. And the reason for that is that if I put anyone to sleep who happen to have exceptionally good questions they wanted to ask, we want to wake them up. So let's make a point of that. What I'd like to touch on, I know that a lot of you do your own work, and that was my assumption. In coming here, obviously, I had to think about what kind of subject would be of use. Most of you who know my writing know that my background is technology and hands-on work. So given that, I threw together some material that actually is based on projects that I've done and processes that you will encounter or that you deal with in restoring your vintage Jeep vehicles. And with that in mind, we're going to move into an item all of you are familiar with. I gave good thought to this, and I knew that we're 1971 back owners for the most part. Is there anyone here that's an exception to that, AMC era? Okay. And that the Ross TL steering gear would be of great interest to you in terms of both safety and drivability of your vehicles. For all the wives and children here, I want to assure you that eventually the goal is to get these vehicles running and be safe on the road. So with that in mind, there really is an objective, and that's what I'm here to help with. We'll see if we can make your vehicle safer. We're going to work our way through a Ross TL steering gear for openers. This sounds like a no-brainer, but a lot of steering shafts have been damaged when the steering wheel gets removed. Removing the steering wheel is obviously something you want to use caution and discretion. One of the things you can do with the steering wheel puller is pad the screw thimble itself and make sure that you don't damage the threads or the top thread. You don't want to spread that steering shaft apart and find that you're looking for another steering shaft. And gear disassembly is always in sequence. If we get hasty or we don't have a shop manual, we can get in real trouble in a hurry. And I want to clarify that with all of my experience, and Keith characterized it in a very flattering way, I always use first generation factory workshop manuals as a guide. We're not winging it, and I've been at this for many, many years. I've been actually working on Jeep vehicles professionally for 43 years. So given that, I will say that things have a sequence, and the sequences are always described in a workshop manual. So to start with, your Ross gear, which you should all recognize, you want to remove those 4 bolts on the side cover as a first step to disassembling the gear. In the process of disassembling the gear, you're curious about how much wear is there. Is this gear in halfway decent shape? Is there a risk? Let's check the bearing play before we disassemble it completely, because we need to know those measurements and to know how much wear is apparent. There's a lot of controversy about what kind of grease to put in these gears. And we have to bear in mind that the recommendations that were made in 1946 may not apply today because there are better lubricants, or lubricants have superseded those types of materials. One of the things that's useful, I find it very valuable, if you have access to, and a lot of you in rural areas where you have bulk plants for Texaco or Chevron or whatever, one of the useful things to do is to get the guides from Chevron or Texaco that cover all of their lubricants. And there are niche products that actually will exceed the quality of the original products that were used in these steering gears. This is a very simple thing. The lever shaft has been removed. Now you have the seal exposed. You can see the bushings and the amount of wear. And again, we're going to review the disassembly sequence so that we avoid damaging the gear. You start removing the pitman arm, then the side cover, then the lever shaft, then the top cover with its shims. You always keep the shims in order. And then you remove the steering worm cam and the shaft, and that's your steering shaft. The Ross gears, this is interesting. All of the Ross gears that we use in the popular Jeep vehicles that I've seen out here are cam and lever designed. Ross built some heavy-duty gears that were very reliable, that were used in medium-duty trucks. I'm familiar with them. As Keith characterized it, I have a background in medium-duty trucks and larger. One of the things I neglected to do in the steering gears that were used in all of your Jeep vehicles, the TL gear, is allow these pins to rotate. They don't. They're fixed to the lever shaft. And as a result of that, since they ride in a groove in the cam, they tend to wear in 2 places, 2 spots on each of the lever pins, 180 degrees apart. So instead of distributing the wear uniformly around the pin, you end up with the lever shaft pins are worn on two sides. They have flats, and you're looking for those flats when you're examining it for wear. This is a close-up. You can see the illustration there. Right in this area, this is actually right here, is a flat that's worn. And the irony is there's virtually no wear whatsoever in the other areas because they're never exposed to the groove. This again is, these are the pins. These are wear points, the highest wear point. I would say that the cam itself, and I've rebuilt a lot of these gears professionally, the cam is very durable. And unless you've had corrosion or moisture or damage caused by elements, or it's been run dry, or you have a situation where there's been physical damage to the vehicle that could have damaged the lever shaft or the pins. Generally speaking, the highest wear point is right here, and the worm itself is reusable. And we'll get to that in a minute. Again, the pin wear. And you might question, okay, well, it's worn there. What can I do with that? Imagine that you've got something round. Now, a flat here and a flat opposite that. If you attempt to adjust the gear, you cannot adjust that wear out of it. And you've actually created, in some ways, a safety issue. You won't get a reliable adjustment out of that gear. Again, the pin is worn right here. This is the cam, or we call it the worm or cam. Rust cam and lever, this is the cam. Generally speaking, it is very durable. It's case hardened, tough material. By design, the friction that it is exposed to does not distribute the load unevenly, and as a result of that, they hold up really well. Inside this bushing, you can use the lever shaft to check the clearance when you're out on the bench, and this is a very easy gear to disassemble. You can see how few steps were involved. It's likely that you can rebuild it yourself if you use guidelines, and that's why I decided to show this particular mechanism. It is something that can be serviced on your workbench with a few ancillary tools like a hydraulic press or arbor press. Anyway, the wear is in these bushings. If you want to know how much wear there is, use your lever shaft. You can use a micrometer to measure the lever shaft. Measure the lever shaft in different places to see whether it's worn at all, and if it's not worn, you can use the lever shaft inside the bushing and actually measure the clearance between the lever shaft and the bushing. And that is the clearance they're referring to in the manual when they say lever shaft clearance. This bushing is more dramatically worn. Again, you could feel that side play if you were moving the lever shaft. Sometimes you can feel that lever shaft movement without even disassembling the gear. If it's severe enough, you can actually feel it by taking the pitman arm and moving it laterally and sideways, so that you're looking for the clearance between that lever shaft that the pitman arm attaches to and this bushing. And there are a pair of bushings. This gear is disassembled completely, and this is a really good indication of what you can do with glass bead blasting. How many people have a glass bead blaster in their shop? Okay, several of you, and I would guarantee that all of you would sing high praises to your glass bead blaster. They can be purchased inexpensively, some of them a couple $100. They run up to, the quality units are about $600. But a glass bead blaster can take a casting like this housing and literally make it look like new. This is the same housing that you saw in the earlier illustration when we took the 4 bolts off the side cover. The same housing. So I mentioned here, you've all seen it, Gliptol, the paint, the reddish paint that you'll find inside these steering gears. That is an anti-corrosive. It's an alkyd. Keith could probably tell me the formula. But the reality is it's a very effective barrier in what I would describe as the Rust Belt threats. And in your climate and everything else, it's a good idea. If it has Gliptol in it, and if the Gliptol's intact, don't glass bead it out of there. Leave it in. Wash it down thoroughly. Glass bead the rest of the housing, but the interior of the housing, this area in here where the Gliptol would be, you want to leave the Gliptol there. Okay, now the bushings, if you don't have, I mentioned an arbor press or a hydraulic press, and again, that is an item that's not exceptionally expensive. I will mention brand names. You can find them from the Harbor Freight level up, and a couple $100 at Harbor Freight will buy you a 20-ton. When they're on sale, they're even cheaper than that. Press. What I like to do is, you can see in this lower portion, this is actually a bushing driver tool that I don't know why they designed these to be hammered on, because they invariably will flare the ends of the bushing if you actually beat them with a hammer as intended. For removing the old bushings, that's not necessarily a bad idea, but for installing new bushings, I always use a press because it's a more controlled kind of force. But I use the collars, this collar, I use the collars that come with a bushing driver to keep the bushing square when I'm driving it in. I mentioned that NOS lever shaft. When you go hunting for parts, and we all know about this these days, NOS is virtually impossible to find. This is the common wear part. This is the lever shaft with the 2 pins that wear. And when you go hunting these parts, you'll find the bushings readily. The bearings are generic. You can get them from a bearing supply. Make sure you're using bearing grade. The shim kits are available aftermarket, and they're not bad. I have some concerns about the aftermarket bearings, the ball bearings and races. The races, if they're offshore, you have to look at them, make sure they're the quality that you want. In terms of an NOS lever shaft for a Ross TL gear, this is virtually a holy grail part, would be a way to describe it. You're looking for something that is near impossible to find. And I've been educated recently to understand that even if it's NOS, and even if it's in a factory box, it doesn't necessarily mean that it is a top quality part. And this is really important to emphasize, because I've always sworn by the use of NOS, if it had the Jeep label on it, it's good to go. In the earliest part of the AMC era, people were taking parts left over. In some cases, they were one-off parts, not way out of tolerance, but not necessarily optimal, and reboxing them in Jeep boxes. And so I would be conscious of that. You want to make sure that the quality of the pins, the lever shaft itself, this is a safety item, obviously. You want to make sure the quality is there. And I'm counting heads here to see how long it takes to exhaust the market. But there were other manufacturers who used the Ross TL gear, Studebaker in particular. And when I was doing mechanical restoration work, I was able to get the TL lever shafts from Studebaker's West and other Studebaker suppliers. And they were NOS genuine Studebaker replacement parts. If we go after them as Jeep owners, and if in fact they have the same pitch on the splines and they will fit, and you have to of course make sure of that, I have a feeling that supply would be exhausted fairly quickly too. This is actually that Harbor Freight press that I'm not embarrassed or ashamed to say I have in my shop. And it's a hydraulic press. This is the bearing driver tool, basically a bushing driver. And I have it on the collar of the bushing, I'm pressing it in. I use the Sunnen, the B200L that I talk about as an anti-galling oil. Machine shops use it. You can get through machine shop supplies. When that bushing goes in, it'll prevent galling or the sticking of the bushing. This is a broader view of the same thing. Be careful when you install the bushings. Don't block the oil holes. Make sure that you position the bushings in the same position that they came out. In other words, if they were in line with the chamfer on the edge of this, below the seat of the seal, that bushing should be in the same place as the original. And that's important because you want bushing alignment that will support the lever shaft. This is the inner bushing. Quite often, a quality bushing will be the right size and may not require reaming. These parts, as we all know, were designed to quickly service something like a steering gear, in some cases in the field. They didn't try to make it complicated and make an undersized bushing that had to be reamed. They're not designed that way. So in many cases, you'll find that your side clearance is right. If you install the bushings carefully, you're able to actually get by without reaming, or a light reaming is all that's required. Didn't beat them in, put them in with a press. This is actually a kingpin reamer. I purchased this through Goodson Tool, and they come sized for, they don't have a large spread in terms of what they'll fit, so you have to make sure you get one that will work with the bushing size that you're working around. And this has actually been reamed. This is the new bushing behind the seal. It's been reamed. Actually finish it with a brake hone. It gives it a slight burnish. It gets rid of, I don't know, all of us have had wonderful experiences with reamers, and you have to use them very carefully because in bronze especially they will gall or stick and they will chatter. And so even with the best reaming, the finish that I put on with the 3-stone hone brings it to the finished surface that I want. Actual tolerance. These are factory tolerances for the Jeep Universals. The Ross TL gear, you can see that's half of 1/1000th of an inch. So be really careful when you ream these things. Don't oversize them or you'll be buying another set of bushings. By the time you finish them with a stone hone, at that point they should finish in this range. And I like to use about 1/1000th for oil clearance. So make it a little bit snug before you actually do the finish hone on it. This is 1/2,000th or 5/10,000ths to 1/1000th of an inch. It's not uncommon. The gear has been disassembled improperly or just in service has had a lot of jostling around. This is a plug at the bottom end of the TL gear. Generally, I will leave that in place if it is not leaking and I don't have reason to suspect there's a seal leak around the base of the tube and the plug. And you'll see oil seep out of these sometimes. If it is leaking, then I will remove it from the housing. And this is actually just a bracing process. I use bronze. And I brace it to the plug without distorting the plug itself. From the outside, from a cosmetic standpoint, you cannot tell that that's been braced. All the bracing's on the inside. And now this will seal. This plug will seal at the bottom end of the housing when I put it back in. Again, glass beading is a wonderful way to check for flaws. I glass bead the worm. I'll show you the results in the next photo. You virtually end up with a surface that if you go over it with a wire brush, I have a wire brush on my grinder with a medium grit, polish the surfaces of the grooves, and that's the result that you get. I'm able to reuse that cam. Same thing on the top end. I glass beaded the whole shaft, so in this case I went back to the wire brush and used the wire brush to polish the threads at the end of the steering shaft and the serrated teeth. Chromium balls are available. I get them from MSC. You can get them from Bearing Supplies. They're inexpensive in bulk, and they're a common size. Like them, you will have no problem matching up the size. The ones out of the packages from MSC are always the right diameter. So that part of it is easy. Quite often the races, because this is not a spinning assembly, the worm shaft is not spinning constantly. So the worm races are generally in good shape. I'll often polish them up with a wire brush and just reuse the races. And they often are in better condition when you've reused the originals than the offshore made in X country replacement races. This Starflex 2 is a chassis grease that I happen to like a lot, highly viscous. I coat the parts with that before assembly. I don't want friction when I adjust it. Now we have the bearings attached to the top and bottom end of the worm. There's circlips that hold the bearings and the races in place. We drop the shaft through. We make sure it's fitted, turning freely. It's a finger press to put that top bearing into the housing. It should not be a force fit. This is the bottom end. This is where the plug will go in. The plug and the horn wire tube that I just braced will go in here. On that end, where I want to get a good seal, I do use good old-fashioned, and this is definitely CJ2A era material, the Formagasket one. It's a hardening type sealant. I'll coat it. This will wipe off with alcohol. You don't want to dilute the material that you put in that bore area. When you wipe it with alcohol, it will tend to dissolve some of this, so be careful when you wipe it, but you can get that excess off readily with alcohol. Here's gasket cinch again. You can coat gasket cinch very thinly on the shims. This will prevent seepage of oil out of the top of the gear through the shims. Threads on the cover bolts can also be coated so you don't get wicking of oil out of there. If you look in the manual, talk about steering wheel in place. You want the worm shaft to be no end play. If you have concerns beyond that or you're a precise kind of guy, you can use a dial indicator and actually physically check to see if there's end play between that worm shaft and where the bearings ride. You move the worm shaft up and down, you check the end plate down at the bottom here. You're actually using a dial indicator. Another way, and this is a technique I use, I'm not going to give you a specific spring tension. We did this earlier today with the steering knuckle, where we knew what tensions we were looking for. This is a fishing scale, but a quality one. And what I do is I wrap a string around the worm shaft. And what I'm looking for is, Jeep is telling me this should be able to turn freely, the worm shaft with the steering wheel. No drag, no notchiness is what you're looking for. If you want to know for sure that you don't have any notchiness, one of the best ways to pull it is instead of turning a wheel with your finger, which gives you leverage, use a spring scale at light tension. And if it's notchy, every one of us is, fiddled with trying to measure a fish. If it's bouncing, it doesn't work. So that notchiness obviously will measure on the spring scale, and you can back it off. You want no end play at all, but by the same token, you don't want a notchiness in the bearings. This goes back to our days when we fiddled with our bicycles. And you tightened the steering head bearings too much, and you couldn't get the bearings to roll, or you started to back off a little bit and it felt literally like it was abrasive. And then you backed off slightly more, no play, but there was a smoothness, and that's what you're looking for. Okay, this is the new lever shaft. This is the indexing point for the pitman arm, and pitman arm only goes on in one position. I'm going to emphasize that too. There is a high point on these gears, and we'll get to that in a minute when it gets to adjusting, but when the lever is actually aligned with the worm cam, if this was on the same plane as the worm cam and not turning, you would want a very slight drag over center. You don't want any drag at all in left and right turn so as you move away from the center. Okay, I'm just cautioning that you should put grease on the seal, and be very careful when you put the lever shaft through the seal. You have the teeth on the pitman arm, and they can be abrasive. They can notch the seal and end up with a seal leak there. so be careful. Coating on each side of the gasket is plenty. Coat the threads, the 4 bolts on the cover. The lever shaft now is in position. You see the worm here. This is one of the pins. The opposite pin is right in this area on the worm. And you can see that this is in the straight ahead position because we see both of the pins engaged. Now, one of the things I want to comment on is when you turn left and right, logically, one of these pins drops out of the worm, the other one remains in it. By the angle, that's the way it's designed to work. So the only point you want to feel drag is just over center. And when you line up your pitman arm and your steering linkage and all of that stuff, there is a distinct goal to make sure that the steering gear is on absolute center at that slight drag point when the vehicle's wheels are in the straight ahead position. Again, you can see the pin in there. The other pin is up in this area here. Gasket cinch. Adjuster screws tend to, they're very hard, they're case hardened. Look for chipping and damage, a fracture. There's a lot of kickback from the lever shaft, and the only thing that is supporting the backside of that lever shaft is this adjuster screw. So make sure it's in good condition, replace it if necessary. Okay, and that's over center drag that I described. You want to turn to the left and right extremes, and you want to use the spring scale to rotate the steering shaft. And actually, you can put the steering wheel on the top of the shaft to simulate what's going on if you're doing it in the vehicle. Or you can estimate the length of the radius of the steering wheel. And if you have a ratchet that's about that length, put the nut on the top of the steering shaft and rotate it with a ratchet, holding the ratchet at the same position that would be the rim of the wheel. And use your spring scale to pull the tension through the center point just to discover where that over center drag is. And it is ever so slight, but the idea is no play there. The specification that you'll find in your manual. And I use gasket cinch on the adjuster screw to make sure we don't wick oil out of there. Check the over center tension again after you've tightened the nut because it can change the adjustment of the screw. So verify that you're still exactly at the same point with drag over center. And if you've done it right, you've just completely rebuilt the Ross TL gear. Again, the next step would be when you install it back in the vehicle, make sure that the pitman arm is in such a position that the wheels are straight ahead when the steering gear is in its centered position, where that slight drag position is. Now we're going to paint it. I've discovered, and some of you may be using it already, the epoxy primers are just outstanding. Get into that a bit later, but the catalyzed primers, they're great for everything except for your lungs. They're not good for your lungs. In that sense, make sure you're using a quality respirator or fresh air system if you're using a gun and spraying it. Believe it or not, as nice as this looks, this is a primer coat, and the epoxy 2-part primers will work as long as you're not using them in an environment that has ultraviolet. Something like the frame, you wouldn't want to use it because it's exposed to sunlight and would break down. But that primer, actually in a non-UV environment, will hold up like a finish coat. And I use it quite often on transmissions, belt housings, and castings. It works really well. The adhesion is outstanding to your lungs as well. So again, use a respirator. The custom application, this came out of a Willys utility wagon. It's a Ross TL. We can see the numbers here. This is 60-61 era. Custom paint job was a request from the customer, mid-50s Willys Kaiser color to match the paint on the vehicle. Aside from cosmetics, this gear is absolutely on the mark for all of its dimensions, the way it'll perform, and the safety. Here are a couple footnotes. We'll go through that. Footnote. This is a tube. You remember me bracing this? When you do not remove the lever shaft before taking the top cover off the gear and taking the worm shaft out, imagine you take the 3 bolts off the top cover and you attempt to pull the worm out of there. You have not removed the side cover or the lever shaft, which I emphasize is the sequence. You end up bending the horn wire too. As restorers, we think about this. These parts are getting scarcer all the time. What can we do to salvage the parts? I braze this. This is easily straightened. A set of E-blocks or whatever, you don't have to get carried away, although this does have to be true because it runs up through the hollow in the worm shaft. So it has to be on center so that when the worm is rotating, it's not scuffing or abrading against the sides of this tube. Dauntless V6 applications. How many 225 V6 CJ owners do we have here? Okay, we've got one. So this is for you. The Ross TL gear, again, in the CJ V6 applications, they had no room for the longer lever shaft. So they went to a shorter lever shaft. It requires special bushings. One of the bushings is longer than the other one because the case is really narrow. You still have to support the lever. So one of the bushings has to be longer to give the same support as the two bushings that are the matching sizes on the longer lever shaft models. One of those bushings, it turns out, if you're getting aftermarket, even quality bushings, I'm fetishist about this. Turns out when you go to install it, it's going to cover the oil hole slightly. We can't have that at the Ludell place. So I take a die grinder and I put this notch and even polished it right here so that when this bushing is installed in exactly the same position as the original, you see how long that bushing is? This long bushing. When that's installed, this will index with the oil hole in the case, and there won't be any obstruction of oil. This is that reamer tool I was talking about. The beauty of using a kingpin reamer, if it has a cone on one end, it's self-centering. You can use that cone to actually true the one bushing that you're cutting with the other bushing. And that's really important because if you cut the bushings separately, you'll end up with misaligned bushings. You might have perfectly sized bushings. You go to push the lever shaft through and it won't fit. And the reason for that is that you've done one bushing, you've done the other bushing, but this plane here, they're not aligned. So using a kingpin reamer that has a cone, this is a cone on this end, that's tapered, will actually feed into one of the bushings, hold it on center while you're cutting the other bushing. You flip it over the other way, and you do the same thing coming back. And in the process of doing that, you end up with bushings that are perfectly aligned and cut to size. This again is a dial indicator being used to measure the lever shaft. This is our lever shaft again. The clearance between that and the bushing. How are you going to measure that? Put your magnetic stand on the housing and measure the lever shaft up and down in this way, and that's the radial run out of the lever shaft. For the gentleman in the back with the V6, this is the lever shaft in your TL gear. If you have an early V6 model, this is the lever shaft. And you notice how much shorter it is than the one that's used in the other models. So to support this with the same stamina that you would find with a long shaft and two bushings, they give you one long bushing and one short bushing to accommodate that. Why is it like this? Remember, the V6 is taking up more space in a four-cylinder chassis, and that steering gear apparently is going to get in the way. Likewise, this is unique to the V6 models. Notice the shape of the pitman arm. And what's interesting in this case, this is a damaged pitman arm. This is the original. When you have early Jeep, all your early Jeep products that have the metal cups and spring-loaded drag links, these are the kinds of problems you have with the ball ends of the pitman arm. So this is worn out. Went to replace it. The only pitman arm available was an offshore source. And I'm going to be really frank about this. The indexing mark to tell you what spline it should align with. Remember that there's an index across the lever shaft. This mark right across here from the factory was non-existent on the new lever shaft. So what I ended up doing is I matched them perfectly. I took the original lever shaft and pitman arm, set them up. You see the levers are down here. And I made sure that they were both aligned perfectly and that I was on exactly the right tooth because, again, we want this pitman arm to be on dead center when the wheels are pointed straight ahead. We want to be on the center of the gear. So the pitman arm position is critical. This is a facsimile of using the spring scale to adjust the worm bearings. I mentioned that earlier. I happen to be using a bar here that has a hole in the end of it that I can hook the scale on, and I rotate it with the spring scale. This is that pitman arm installed. It's getting ready to be painted. This is the paint that I described earlier, two-part catalyzed epoxy primer. It's actually a primer. Put on a nice even coat, looks like a finished coat. Okay, that's it for the Ross TL gear.